When you look at a world map, most of the time you see, on one side, the continents with their varied and marked reliefs, their plains, their canyons, hills, and mountains. And on the other side, the oceans that seem uniformly blue, flat, and monotonous. Except that if these maps accurately reflect the tumultuous history of the continents that have torn, collided, or fragmented over time, they do not at all do justice to the torments that hide beneath the surface. They ignore what happened under the waters. Yet the Earth does not end where the sea begins. The ground never really disappears. Under the water, it continues, it sinks, it dives out of sight. And if we can no longer walk there, it's simply because we have nothing left to lean on. As you will have understood today, I would like to take you to the other side of the mirror to discover pieces of land that have returned under the seas, of mournful continents, of thousands of islands that have ended up sinking, of long chains of mountains lost, forever hidden and drowned. And to start this dive to meet these submerged worlds, let's start by looking at what we find in the largest ocean on the globe, the Pacific, where we have unearthed the largest submerged structure on our planet. A continent that literally ended up sinking some 80 million years after detaching from the ancestors of Australia and Antarctica, this giant named Zealandia. We've covered this extensively in a prior episode, and so I'm not going to elaborate any further on the history and origin of what many geologists consider to be the eighth continent. But keep in mind that there currently exists there, in the South Pacific, lying more than 1,000 meters deep, a huge continental crust that, if it rose above the waves, would give birth to a landmass twice as large as Greenland. And above all, that this sunken continent is far from being the only stone giant hiding beneath the seas. Because there are many other structures down there, just as strange, monumental, and often unknown. Moving away from Zealandia to take in the entirety of the Pacific Ocean floor, one can see areas that seem darker than others. These long and narrow gashes, which can stretch for thousands of kilometers and reach depths of 10 kilometers below the ocean's surface, are trenches, oceanic pits. They have been as if dug by the crusts of the same name, making up the Pacific as well as other oceans, and which slide under those of the continents, before diving towards the depths of the Earth. As they sink, these plates, which are said to be in subduction, will be heated and see their constitution change, to the point of partially merging by fusion, and thus generate, near where they sink, the formation of long chains of volcanoes fueled by their decomposition. The sinking crusts are responsible for the Pacific Ring of Fire, which spans over 40,000 kilometers and borders nearly the entire vast ocean. And above all, it hosts nearly 75% of the active emerged volcanoes on our planet, while concentrating 80% of the surface earthquakes. And what if these intense volcanic activities have given birth to structures visible even from space, such as a large part of the 7,000 kilometers of the Andes mountain range? In South America, they also generated immense structures, the vast majority of which are hidden under the waters. Like here, where this long mountain range, this volcanic arc of the Oceanales that stretches over 1,700 kilometers between Alaska and Kamchatka, is actually only the visible part of a much larger whole, which can only be appreciated when one is interested in what is happening beneath the surface. Removing the oceans reveals the true scale of these seemingly modest volcanic islands. Gigantic mountains as large as the most colossal of our peaks, White Mountains of the Great Blue, with only their caps visible to us. These rise from the bottom of the seas, situated 218.72 yards below their shores. And following to the west, the trench of this oceanic trench formed by the subduction of the Pacific Plate under the North American saddle. We arrive at the imposing Kuril-Kamchatka Trench, which, with depths reaching 10,500 meters, has given birth to imposing terrestrial mountain ranges as it dives into the depths of the globe. Further south, still underwater, we find another oversized relief of the same type. Another gigantic volcanic arc, rich in hundreds of active volcanoes that run for nearly 3,000 kilometers south of Japan, although it averages several thousand kilometers above the ocean floor. This structure of more than 1 million square kilometers, an area equivalent to that of Bolivia, is not high enough to break the surface. Yet at this spot where the Pacific Plate slides a few centimeters per year, under the Philippine Plate to the north and the Mariana Plate to the south, it could well emerge from the water after a few million years of intensive volcanic activity. An imposing exposed strip of land. Further south, a few thousand kilometers from there is a strange gash that extends from the northeast of New Zealand to the Tonga Islands. This subduction zone, named Kermadec and Tonga, is the second deepest ocean trench in the world. Here, the Pacific plate dives 874 yards below the surface before disappearing under the Indo-Australian, contributing to the formation of a large number of both submerged and emerged volcanoes. But the 70 underwater mountains that you can see lined up on this long chain called Louisville, and the oldest of which were generated a long time ago. 80 million years owe their existence in no way to this subduction zone. Because even if many mountains and volcanoes are formed, when two tectonic plates meet, it also happens that we find them formed far from any friction or contact zone. This is the case with these latter ones, which all formed above a hotspot. Today, Sleeping is located more than 4,000 kilometers from there. And if this hotspot has ended up declining and stopping spitting, others are still very much alive. We find immense necklaces of volcanic pearls in several places around the globe. The most emblematic representative of which is certainly the underwater Hawaii Emperor chain, which crosses a large part of the North Pacific. From the main island of Hawaii to the Kuril-Kamchatka Oceanic Trench. Because the Hawaii hotspot, which is the most active in the world, has not only produced the 8 islands we see today, but has also left a footprint that extends and continues underwater for about 6,200 kilometers up to the Oceanic Trench, near which the oldest underwater mountains of the chain are located. And if the roughly 130 volcanoes that make up this long, primarily underwater chain, and which were all born more or less here, are today so far apart from each other, it's because the plate on which they rest has moved since their formation. While the gushing lava fountain that gave them birth, the hotspot from which the magma rises from the bowels of the earth, has remained stationary. Here, as with the Louisville chain, the orientation of the underwater mountains roughly indicates the direction of the movement of the oceanic plate on which they rest. We can even see, by the presence of this marked elbow, that its movement has abruptly changed direction. This happened some 50 million years ago. We know today that the youngest islands of this long structure are barely 300,000 years old. The one at the end of the chain is nearly 100 million years old. But it is very possible that the activity of this hotspot goes back even further in time. We cannot know if even older underwater mountains were formed here. They have likely been as if erased. Because by disappearing under Russia, by sinking into the Earth's upper mantle, the Pacific plate takes with it the piles of lava it carries. Slowly sliding, it erases the traces of the past. Perhaps a day will come when the main island of Hawaii, which is formed from a pile of accumulated lava from its base resting at the bottom of the ocean, at its peak higher than it is, Everest, will in turn be erased from the map by the movement of tectonic plates and their sliding steamroller. In the meantime, this accumulation of cooled magma is nothing in terms of volume compared to the largest colossus of lava recently discovered under the seas. The largest volcano on Earth, the Tamu Massif. A colossal undersea volcano, 310.689 miles east of Japan, with a volume 50 times greater than Hawaii's Mauna Loa. The origin of this monster, whose area is similar to half of a country like France, is closely linked to that of the immense plateau known as Shatsuki-S, and to which it is attached to the western part. This oceanic plateau, the third most imposing in the world, seems to be split in two today on either side of the Hawaii Emperor chain. But it is believed that these highest reliefs, about 2,500 meters above the ocean floor, were formed after several million years of almost uninterrupted eruptions that took place several thousand kilometers from where they are found today. They are in a way witnesses to a turbulent tectonic history, from which we can, as we move away from the immense Shatsuki-S, go back in time, by following this long tail that narrows and points towards a declining hotspot, and today extinguished. Further south lies another oceanic plateau. The Central Pacific Mountains clearly stand out from the apparent monotony of the surrounding abyssal plain, above which they rise to more than 2,000 meters. It is thought that this vast relief, which began to form at the beginning of the Cretaceous, was also born vertically. from a hotspot and a fault system located several thousand kilometers away, before slowly drifting north. And here again we can try to find its birthplace by tracing this long and thin string of underwater volcanic islands, which seems to lead us to Polynesia at the level of the Tuamotus, before branching off and getting lost in the direction of the hotspot of Easter Island. And it is strange to think that, for tens of millions of years, this formation was, and presumably, a huge archipelago of vast and majestic tropical islands, which moving away from any lava supply. Due to erosion, they collapsed, surrounded by reefs, transformed into atolls, before inevitably ending up sinking, at the end of the Mesozoic, about 70 million years ago. On this vast plateau, we find the remains of old underwater mountains and dozens of extinct volcanoes. On a planetary scale, lava continuously flows underwater, with an estimated average of 20 ongoing eruptions. There now, at the bottom of the oceans. And in the past, these have often spewed out prodigiously huge volumes of magma, as evidenced by the presence, in the southwest of the Pacific Ocean, of two immense oceanic plateaus that you have almost certainly never heard of, Ontong Java and Maniki. Yet, these stone giants lying beneath the seas and still rising more than 2,000 to 3,000 meters above the ocean floor are the remnants of an end-of-the-world cataclysm, because they were formed during the largest volcanic event that our planet has known over the last 200 million years. It is believed that the eruption that gave birth to them most certainly massively acidified the oceans and pushed many species of our planet towards the exit door. This happened about 120 million years ago, when Australia and Antarctica, then stuck together, began to separate, stretching in their wake the bottom of the ocean, to the point of eventually tearing it apart. The magmatic outpouring that followed then spat out a volume of lava equivalent to 4 eruptions of Pinatubo per year, almost continuously for 3 million years. When everything was finished, the Ontong Java Manaiki Plateau formed a territory as large as a country like Mongolia, and then covered 1% of the surface of all the emerged lands of our planet. And then, as the Australian and Antarctic continents continued to drift apart, the immense plateau in turn tore into several pieces. Ontong Java, the largest of these fragments, is unfortunately destined to disappear, because the movement of the plates, by gradually pushing it into the Solomon Trench, is erasing it. As for Maniki, it is believed that it may have had hundreds of islands protruding from the surface in the past. Today, it is only punctuated by underwater mountains and has only 3 small atolls as its only emerged land, lost in an expanse of 770,000 square kilometers. Imagine, for the sheer pleasure of speculation, the influence it could have had on world history. The presence here, at the crossroads between Melanesia, Micronesia, and Polynesia, of such a large emerged land. But let's now leave the Pacific Ocean to go explore the Indian, in which we find many underwater rocky structures exceeding in surface area many of our countries. Starting with the Kerguelen Plateau, the second largest landmass lost under the waters of our planet. There, 3,000 kilometers southwest of Australia, we find submerged in deep water, a huge underwater plateau made up of submerged volcanic and sedimentary rocks, and which has all the characteristics of a microcontinent. Stretching nearly 2,200 kilometers wide, the whole covers an area of over 1,200,000 square kilometers, which is more than twice the area of metropolitan France. From this large structure, which rises on average 2,000 meters above the surrounding seabed, now only a few islands protrude above the surface. But it has not always been this way. Consider that there, at the bottom of the sea, are sedimentary rocks, similar to those that litter the grounds of certain regions of southern Australia and India. The deposits at the bottom of the waters indicate that these continents were once connected, and that the vast Kerguelen Plateau shares a common past with them. This was some 120 million years ago, when the supercontinent Gondwana began to break up, and with the opening of the Indian Ocean, the Kerguelen hotspot abundantly fed magma to the surface of this part of the world and formed the Kerguelen microcontinent, a landmass that then protruded well above the sea in places. High peaks, long mountain ranges, and vast forests stretching as far as the eye can see. Numerous drillings have indeed been able to show the presence of charcoal in the underwater rocks of this region, which would have formed at a time when a large part of the plateau was above sea level. and covered with large and dense coniferous forests in the middle of the Cretaceous a few 100 million years ago. What will become later? The Kerguelen was then an island as vast as Japan, dotted with mountain peaks cheerfully exceeding 2,000 meters above sea level. Then, some 40 million years later, a large part of the microcontinent ended up sinking. Throughout its long history, it is believed that on several occasions, large portions of this plateau were exposed to the open air for millions of years. The object then appeared to split in half, with a portion of it disintegrating. Indeed, to the west of Australia, there is an oceanic plateau larger than Portugal, which was once one with the Kerguelen, before they were caught up in a tearing movement when Australia and Antarctica began to separate. And even if the peaks of this imposing mass currently lie 1,000 meters deep, everything suggests that at the moment they were torn from their original microcontinent, they were then proudly protruding above the waters. Starting from this broken ridge, to the north, we find an immense mid-ocean ridge that runs for nearly 5,000 kilometers, up to the Bay of Bengal, where it disappears under a mad advance of sediments. It is thought that this strange structure also owes its origin to the existence of a hotspot located below the Kerguelen, and which would have, 80 million years ago, begun to give it birth, by regularly and almost continuously spewing lava on the plate, sliding north above it. And I must say, to have fun, imagining what this region of the world would have been if this ridge, covering a total area of nearly 750,000 square kilometers, the size of a country like Chile, which it strongly resembles, I find, had risen above the ocean surface. Today, this 200 km-wide geological structure is entirely hidden beneath the ocean. But deep surveys have found in some rocks of this chain pollen and fragments of fossilized plants, suggesting that about 60 million years ago, parts of it were temporarily exposed to the open air. Further west, in the central part of the Indian Ocean, there is another submerged structure that is just as astonishing. This vast strip of submerged land began to form during the Cretaceous period, some 30 million years after India and Madagascar had separated. At that time, what is today? The hotspot located under Reunion Island released into the central part of the Indian subcontinent huge amounts of magma that, by stacking up over thousands of meters, gave what is called the Deccan Traps. And as the subcontinent continued its ascent to the north, leaving the hotspot behind, it continued to spew and give birth to new lands piercing the ocean surface. Thus was born the vast Ishago-Laccadive Plateau, as well as the archipelagos of the same name and the Maldives Islands, which are the emerged remains of a much larger ensemble, buried on average 1,000 meters below the surface. Further south, there is another immense structure, also largely underwater, which extends for about 2,000 kilometers, from the Seychelles to Reunion Island, where the still active hotspot that gave birth to this ensemble spews. Consider that here, it is sometimes only a few meters below the surface. A territory as vast as the island of Cuba, which rises 4,000 meters above the surrounding abyssal plain. The Saya de Malabank, for example, which formed 35 million years ago above the Reunion hotspot, is today nothing more than a vast array of seabeds covered with remnants of shallow coral reefs. But this region was, millions of years ago, a large group of mountainous volcanic islands, covering an area as large as Belgium. In fact, on this immense mascarene submarine plateau, one can find a large number of remnants of coral reefs of submerged atolls, all of which suggest that once a large part of this territory was above water. And since the majority of this plateau was located at depths between 8 and 150 meters, many of these remnants must have been low islands. Only 20,000 years ago, during the last ice age, the sea level was 120 meters lower than it is today. And I must say, I like to think about the fact that before colliding and merging with the Asian continent, the Indian subcontinent literally passed through there. In fact, in the Seychelles, we find basalt deposits from the colossal volcanic eruptions of the Deccan, which occurred in the central part of the subcontinent, and are thought to have contributed to the extinction of the dinosaurs. In this part of the globe, the Mascarene Plateau is not the only huge aggregate of rocks hidden below the horizon. Indeed, Even further south, a few thousand kilometers from the Malagasy coasts, we find what is called the Walter Banks, a kind of small continental fragment, a set of submerged mountains whose peaks, flattened into plateaus in the southernmost part, are only 18 meters below the water's surface, which means that, once again, a large part of this region was exposed during the last glaciation. In fact, if this vast portion of land attached to Madagascar exceeded the surface, the island would see its area practically doubled, to reach roughly that of South Africa. A country off the coast of which are under the water's two other plateaus that rise to 2,500 meters above the ocean floor that surrounds them, and which formed after Antarctica, Africa, and South America detached. In other words, they are somewhat the fragments of a tear involving three continents, but also the supercharged activity, a few 100 million years ago, from a hotspot named Meteor. And moving northward in the southern Atlantic Ocean, one can encounter imposing underwater masses, having a common past and whose arrangement tells us a story at the beginning of which an ocean opened. To the east lies the Walvis Ridge, a series of underwater mountains, some rising over 543.744 yards above the ocean floor, and which extends over more than 3,000 kilometers from the mid-ocean ridge to the north of Namibia. And, on the other side, relatively close to the coasts of South America, there is another formation that seems to have been built in mirror the Rio Grande Rise, which some call the Brazilian Atlantis, because granite blocks have been found lying on this vast protrusion that rises above the surrounding ocean floors, a type of rock that is usually only found on continents. This roughly symmetrical configuration is the result when South America separated from Africa, opening the Atlantic. Around 120 million years ago during the Lower Cretaceous, these two structures started forming in the same location, more or less. Here, where the magma was then gushing from the bowels of the Earth at the so-called Tristan hotspot. Then, over the millions of years that followed, as the basaltic lava flows continued to break through the surface, these formations, becoming increasingly vast, began to drift with the sliding of the oceanic plates and the opening of the new ocean. And what will become later, the Walvis Ridge and the Rio Grande Rise have, by force of circumstances, taken different directions. Originally side by side, these immense basalt deposits, carried away by the movement of tectonic plates, gradually separated. And what if today, the activity of the aging Tristan hotspot has significantly declined? Are other regions of this ocean currently the scene of regular and much more intense volcanism? To encounter them, let's head north towards the Azores archipelago. This relatively young landmass has been an active volcanic zone for about 7 million years. At this point, the North American, Eurasian, and African plates form a triple junction where each takes a different direction, and the magma that manages to pierce the crust here has ended up giving birth to 9 emerged islands. The plateau on which they rest is almost as large in area as a country like the United Kingdom. And 1,000 kilometers south of the Azores is the underwater mountain known as the Great Meteor, one of the largest flat-topped mountains on our planet. There, 270 meters below the surface, lie the remains of a building whose area is comparable to that of Mauritius. Rising nearly 4,000 meters above the surrounding seabed, the peaks of this sunken island have long been eroded, smoothed by the action of the waves. But there was a time, millions of years ago, when the Great Meteor, before collapsing, was exposed to the open air. In all the oceans of the planet, sometimes only a few hundred or even tens of meters below the surface of the waves, one can find mountains. Today we know of nearly 100,000 underwater mountains over 1,000 meters high across all the ocean floors of the globe. And the number of those exceeding 100 meters is estimated to be nearly 2 million. Consider that if all the underwater mountains of the Pacific Ocean alone were gathered in one place, then their area would be roughly comparable to that of Europe. In fact, northwest of this continent lies a vast accumulation of rocks that formed long before Iceland's birth. Between Greenland and Europe, there is about 55 million years. Today, from this kind of unfinished continental fragments, nothing stands out, except for the astonishing isolated islet of Rock Hall, which, although it only rises 21 meters above sea level, is the highest point, the weary summit of a protrusion as large as Ireland, buried under several hundred meters of water. Many more examples could be given. But since we have to stop somewhere, we are going to complete our world tour of the deep sea by going to the far north. By following the oceanic ridges from Iceland, until we finally find, at the end of the Geological Ridge, a strange formation 100 kilometers long and 40 wide. An underwater caldera formed by the eruption of a supervolcano that exploded under the waters of the Arctic millions of years ago. For so long, we have ignored, passed by all these submerged giants, these aborted mini-continents. There are definitely under the waters a large number of other blue planets. A big thanks to the City of the Ocean and the Biarritz Aquarium, without whom this episode wouldn't have been possible. If you are passing through or living in the southwest of France, it's a perfect stop to get your head underwater while staying dry. At the aquarium, you can observe many of the fascinating inhabitants of the underwater worlds up close. On the other side of the glass of one of the largest tanks in France, you can, among other things, contemplate nearly a dozen different species of sharks. Here, jellyfish with undulating umbrellas, they're myriads of fish from a Caribbean lagoon. At the City of the Ocean, you will discover a lot of fun and intelligent content about the ocean. Exhibitions, workshops, and experiences to understand while having fun. And that's even the face you might make when discovering, like me, the exhilarating and disorienting sensations caused by virtual surfing on a dynamic board. For their support, cheers to them, and above all, cheers to you,